everybody, today we're going to talk about dissociation equations. So we looked at how substances dissolve yesterday, in particular ionic compounds. And when ionic compounds dissolve in water, the water molecules surround each of those ions and essentially pull them off of the crystal structure of that compound. All right, so we've got an example here of classic sodium chloride. Take a look at the structure, the different ions that we have here. We've got positively charged sodium ions, negatively charged chloride ions. When this dissolves in water, remember the water molecules will surround each of these, because water molecules are partially charged. And start pulling them off. And when that happens, we end up with these separated from each other. I left the waters out of here just for clarity so we can see a little bit better with this. All right, so we've got an ionic compound that has dissolved in water and separated into its component ions. And that's fantastic and great, but we want to learn a way to convey this a little bit easier, to represent it using symbols instead of having to draw this out all the time. And chemists are really good at using symbols, and scientists are really good at using symbols to show what's happening. Okay, so I'm going to go back to our screen here. If we look at this real quickly, if we counted the sodiums and the chlorides, we would have 8 sodiums and 8 chlorides. So we've got a ratio of 8 to 8, which we could simplify to 1 to 1. And the formula unit then for sodium chloride is NaCl, all right, a 1 to 1 ratio. We want to show what happens symbolically when that dissolves or when that dissociates in water. So I'm going to put up the equation here, and this is what it looks like. We started off with NaCl as a solid. This parentheses here, or the S in parentheses, says that it's a solid. And we'll use an arrow to show what this breaks up into. It breaks up into the Na plus ions and the Cl minus ions. You'll notice this AQ after the Na and the Cl. That's telling us that it is aqueous, all right, meaning dissolved in water. So we call this whole equation here a dissociation equation. We'll get some practice writing these and also identifying if they're correct. And there's a few things we can look for to make sure that a dissociation equation is correct as we move on. Actually, right now we can talk about, like, one of the things is the atoms have to be balanced. Notice on the left side of the arrow here, we've got 1 sodium and 1 chlorine. And on the right side of the arrow, we've got 1 sodium and 1 chlorine. So the atoms are balanced. That's nice. The other thing that has to be balanced is the charge. This gets a little tricky as we haven't done much with charge yet, but we're going to get a whole bunch of practice with it moving forward. If we look on the right side here, on the product side, when I say products, I mean right of the arrow, we've got a plus charge and a minus charge. And if there's no number written after it, we understand that to be a 1. So a plus 1 and a minus 1. And if we add those two together, plus 1 minus 1 adds up to 0. If we go over on this side, to the left of the arrow, we notice there is no charge on here. So we have no charge on the left side, no charge on the right side, and our charge is also balanced. So the things we want to look for in a correct dissociation equation are balanced atoms, or balanced particles, if we want to count ions, and balanced charges. All right. In the practice section, in the assignment that you have on Classroom, you'll notice a copy of this slide there. We just worked out this one, and we saw where that came from. We'll look at one more with the aluminum chloride, because that's a little bit different. It's the same idea, just a little bit more complex. And then I'll show you the answers for the last 2 that are on here. All right, so aluminum chloride would look something like this. Notice it's not a 1 to 1 ratio like we saw with the sodium chloride. If we counted everything up here, we would see 2 aluminums and 6 chlorides. So a 2 to 6 ratio is the same as a 1 to 3 ratio. So the formula for aluminum chloride is AlCl3. And similar to how the sodium chloride dissolved in water, when this dissolves in water, it's going to separate into those component ions, and it would look like this. All right, we still have that same ratio. Nothing was created, nothing was destroyed. We just want to represent it a little bit differently. So here's the written out dissociation equation for aluminum chloride. We notice that we started with AlCl3. All right, I'm going to give you formulas like this. You're not going to have to write those on your own. Saying that it was a solid in the beginning. It dissolved in water and split up into Al plus 3 plus 3 Cl minuses. Notice the 3 over here is telling us we have 3 chlorides. So I want to make sure I reflect that or represent that over here. So the chlorides, there's 3 on the right side, 3 on the left side. The aluminums, 1 on the right side and 1 on the left side. So the number of atoms are balanced here. Where it gets a little bit tricky is the charge. Right? If I look at this right away, I see a plus 3 and a minus 1, and I might be tempted to say, oh, that's a plus 2 over here. And on this side, it's 0. Here's a big hint. It's always going to be 0 on this side. But what I failed to account for there was the 3 chlorides. So there's 3 of those. Each one of them is a minus 1. So we end up with a total of negative 3. And the negative 3 and the positive 3, those add together to be 0. All right, so we always want this to add up to 0 on this side because we're starting with a neutral compound every single time in a dissociation equation. All right. The other 2 that were on the page look like this. This one's a little bit trickier. This one is barium nitrate. And oh my gosh, we've got this horrible looking thing in parentheses here. I'd encourage you to look on the back of your periodic tables. This is what we call a polyatomic ion. And they stand out because we notice that a lot of times we have 2 capital letters right next to each other. All right. And oftentimes there's a little subscript next to it. That just tells us that this is a polyatomic ion. This NO3 always travels together and stays as a group. All right. It seems a little bit more complicated, but you guys will handle it just fine. We'll roll with this. The dissociation equation, we're going to split this up into the ions that are there, a barium, and then we're going to split it up into the nitrate. And we'll keep this whole thing together. Instead of splitting it up into nitrogen and oxygen and having all that mess, let's just keep it together as nitrate. All right. So the barium 2+ ion is right here, and the nitrate is over here. We'll get really good at determining what these charges are. If we looked and found barium on our periodic tables, barium's in the second group, and that's always going to be a +2 charge for barium. All right. There's some other ways to cheat, and the more you practice on this, you'll figure out how to do those cheating methods. But use your periodic tables. It's really going to help you out with this. All right. So 1 barium, 1 barium. The nitrates, and count the whole thing, NO3. There's 2 NO3s on the left side and 2 NO3s on the right side. So we got a total of +2 from the barium, -2 from the total number of nitrates, and +2 minus 2 is 0. We always want that charge to add up to 0. We have the solid and the aqueous on each of those different ions. All right, for the iron 3 chloride here, a very similar thing. This one's not a polyatomic. All right, it might get a little tricky to figure out what the charge is because iron's a transition metal, and it's a little bit trickier. You can't predict that just from where it is on the periodic table. But we do always know what chlorine is. All right, chlorine's way over in group 17. That means it's always going to be a -1 charge. So when we split these up, we've got that Cl -1, and there are 3 of them. So even if we didn't know what the iron was, well, let's pretend this isn't here right now. If I have nothing there for the iron, I know that the right side is a total of -3, and therefore the iron has to be a +3, so that cancels out to be 0. All right. If that's a little confusing, it's okay. I understand we haven't done a lot of formula writing and work with ions. Good news for you is I'm not going to have you write these from scratch. Instead, I'm going to have you find out which ones might be correct from a few choices for dissociation equations. All right, that's for tomorrow. So you'll see the assignment coming at you in Classroom. You should see that. Hopefully, I did get a little bit of feedback, and hopefully everybody's finding this a little bit easier to navigate instead of having a whole bunch of links in different places to find. I put all of your assignments in one place here. And just streamlined it a little bit from yesterday. And so I was going to have what unit we're in, what lesson it is in the unit. Our learning target and language objectives will always be here. So today we're representing dissociation of ionic compounds using chemical equations and reading dissociation equations using chemical symbols. But as far as the lesson goes, the instructions just go 1, 2, 3, 4 on here. You're going to start out, and you already did this part. You're going to be watching the video. All right, that will change by tomorrow. You'll watch the video. Here's a bonus video if you don't care for mine. You can check out Melissa Maribel. She's awesome. The key concepts, you can click here, or it's going to take you down into this part. This is just the notes that we saw in the video. The practice in this case, I'm going to ask you to take a look at different dissociation equations. For instance, lithium chloride. I'm going to have you highlight the correct choice. So if you think this one's the correct choice, I'm not saying it is, you would come here and give it a highlight. Pick your color. It doesn't matter. Whatever you feel like. Whichever one you think is correct, you'll highlight that one. You've got 10 problems. And if you want, you can check your answers here. That'll take you to a different document with the answer key, or with the answer key. That ought to do it for the practice. When you're done with all that, here's a link to a quiz. As far as the quiz goes, I'm going to let you be honest with me and just self-report what your score was on the practice. All right. And that includes, if you check out the key and you fix it, just tell me what your score was on that. I expect lots of 10s out of 10s on this. All right. Thanks for tuning in. Hopefully everything's going well for you. Please always send me your comments and questions, and we'll try to get those taken care of. All right. Hopefully you guys have a great day, and we'll talk again soon.